Today's lesson, we are going to look at special segments in a triangle. Our first special segment is called a median. When you hear the word median, I want you to think of middle or midpoint. To draw in a median, I am going to take one vertex of my triangle and I am going to draw a line connecting the middle or the midpoint of the other side here. Because our median is going to the midpoint, this other side of the triangle is split into two equal parts. This fact becomes helpful if we look at the example right below where they're asking us to find x if EG, so I'm going to highlight that segment EG, is a median in triangle DEF. So right away we know the median is going to split that side into two equal parts. I can go ahead and mark that diagram with some congruent tick marks. More importantly, I'm going to set up an equation here. I'm going to use 5x minus 17 equal 3x plus 1. From there, I can use my algebra skills and solve. Start by subtracting the 3x on both sides. Leaves me with 2x minus 17. Bring down the 1 on the other side. Add 17 on both sides, leaving us with 2x equals 18, and final step, divide by 2. So we're going to get an x value of 9. All right, if we look at our second special segment, an angle bisector, we've actually seen the angle bisector before in our first unit. If you recall, bisect means we're going to split into two equal parts. So I'm going to pick one angle in our triangle, and I'm going to draw a line that's splitting that angle into two smaller equal angles. And I can go ahead and put those tick marks there. So when you see that angle bisector, I want you to think about one of the big corner angles of our triangle being split into two small equal angles. So let's look at our example. DF bisects, here's our word bisect, angle CDE. So I'm going to find that angle CDE, and that line that's running through is going to split that angle into two equal parts. Since we have one of our angles is 4x plus 30, I set it equal to our other angle, 8x. All right, let's move our x terms to one side, subtract the 4x, bringing down the 30, and we have 4x on the right side. Let's divide each side by 4, and we're going to get an x value of 7.5. So there's our angle bisector example. Now, before we look at our other two special segments, I want you to pause right here and look at the difference in our pictures. So we have one picture, the median on the left side, where we are splitting the side of the triangle into two equal parts. And then on the second example, angle bisector, we have a special segment that is splitting the angle into two equal parts. Here we are with our last two special segments in our triangles. We're going to look at the altitude here, which means perpendicular to our side. In order to draw this altitude, we're going to take one corner of the triangle and we are going to draw that straight down. Remember, perpendicular lines should form that right angle. We have 90-degree corner there. So when I look at our example right below where it says AB is an altitude and we want to find the value of x, I'm going to highlight that altitude. And remember, the only thing we know by definition is that line is going to meet at a 90-degree angle. So I'm going to fill in that 90 degrees right here. And really, you can fill that in on either side. Notice they have some segment lengths, but I'm going to cross those out. Those are not helpful when we're talking about an altitude. So don't get fooled, don't get tricked by that value. When we want to set up an equation to find x, the only thing that I know is that our angle 4x plus 10 equals 90 degrees. From here, we'll go ahead and solve, subtract 10 on both sides. Brings down the 4x and we have 80 on the right-hand side. Divide by 4. We are looking at an x value of 20. Nice job with the altitude. Final special segment in our triangle we're going to talk about today is a perpendicular bisector. Now our perpendicular bisector is going to share some qualities with the altitude because we know perpendicular meets at a right angle. The difference here is because our line is going to bisect the opposite side, it may not go through the corner of the triangle. So I need to find the middle of the side because we want to bisect the side, and then we want to go perpendicular, so I'm going to draw a line straight up and down with those right angles there. In this special segment, we have two things happening. Make sure to write that down on your drawing. One special thing to note, if you want to look back at the altitude and compare these two special segments, notice the altitude is going through the corner angle of the triangle. The perpendicular bisector is not going through the corner, and it does not need to go through that angle. So let's take a look at an example below where it says that line SR is a perpendicular bisector in this triangle. We're going to find the missing value of x and y. So right now this line is coming through. Remember, perpendicular means right angles. So I see they already have a right angle marked for me. Just to help out, I'm going to fill in 90 on both parts here to help myself with those angles. Also, bisector means it's going to split into two equal parts. So I'm going to put little tick marks here on the two sides of the triangle. Your choice, which one you want to solve for first, x or y. I'll just start with x, so those are my side lengths. So we have two equal side lengths, so I'm going to set up that equation 13x minus 5 equals 10x plus 7. Okay, let's subtract 10x on both sides, bringing us down to a 3x. Add on 5. So 3x equals 12. Final step, divide by 3. And our x value is 4. Don't forget, they want us to find y. So second equation, locate that y, and that is part of my angle. See how it says 6y plus 12? And remember, that angle is 90 degrees because we are hitting at a perpendicular or right angle. Go ahead, subtract 12 to start your solving here. So we have 6y equals 78. Final step, divide by 6. And it looks like our y value is 13. Just to recap here, notice our altitude and our perpendicular bisector are creating those right angles, those 90 degrees. The difference is where do they hit on the side of the triangle. An altitude can hit anywhere. It doesn't necessarily have to go through the middle, where a perpendicular bisector will go through the middle of that side. So it gives us that extra piece of information, knowing that we have two equal side lengths there. Now you know everything you need to know about special segments in triangles.